Alright, so in this lesson we're going to go through transformations of graphs, which is really just one step further than everything we've done prior. It's just going to add in graphs instead of points. And it sort of brings together what we learnt right at the very start of the set with, the chapter, with what we're doing now with matrices. Alright, so just bear with me and we'll see if we can have it get through this. Okay, so here's a question. We've got a transformation defined by this matrix. We're going to find the equation of the image of this from this transformation. All right, so we just need to find out what the new graph looks like. So if you wanted to know what this one looked like, you'd have a, it's a positive quadratic. It goes through at positive 3. Its factors are, was it 3, 1, don't think it has any factors because 3 times 1 is 3, but 3 plus 1 is 2. If that was a minus, that would be a negative 3. If that was a minus, that would be a negative 3. Alright, so it doesn't appear unless we can use the quadratic formula. Why don't we use b squared minus 4ac, so 2 squared minus 4, 1, 3. So we can see here it's going to be 4 minus 12, so there's no factors. Alright, so it's just going to look something like this, doesn't matter what. Alright, and then we're going to transform it using this matrix. So we're going to move it somewhere, whether it's dilation, left, right, up, down, or reflection. Okay, so that's the general idea of the problem, to find out the transformation of that quadratic. Alright, so I'll just erase this, and we'll get into it. So the first thing you want to do is to identify some key information. So we're just going to use the point. We're going to say that every point on the quadratic maps to some other point, which is the image of that point underneath the transformation. All right, we'll use the transformation matrix like this. We'll multiply it by the point we want to move, and we'll tell it that it equals the image of that point. All right, so now you might remember that if we wanted to find out what x, y was, we have to, instead of dividing by this matrix, we multiply by its inverse. So the new equation is going to be xy equals the image multiplied by the inverse of this one. We can write it like this, to the power of -1. All right, so we need to find out what the inverse of that equation was. Oh, by the way, if you're wondering why I've done this step here, I'll write it over here using a different notation. This transformation matrix we'll call T, this one we'll call X, and this one we'll call image. You might remember that when we want to find out the rule for a transformed equation, we need it in the form of X equals, because that's what we're going to sub into this to find out what the image is. All right, so we need it in x equals. So the equation we had was tx equals the image. All right, but we need it in the form of x equals, so I'll divide both sides by t, which is the same as doing the inverse, and I have x equals the image multiplied by the inverse. All right, so this is now the equation that I'm going to do in matrix form. All right, so let's find the inverse of t. Now the inverse of t was 1 over those two minus those two, so that's 1 over 2. And then we can, what did we have to do? We had to make the zeros negative, which does nothing, and swap a and d around. All right, so keep finding the inverse. We'll multiply this half through the, actually I'll get rid of that. We'll multiply the half through the matrix, so we end up with 1, 0, 0, and a half. All right, so this is the inverse of the transformation matrix, because we needed to find that to multiply it to the image of the points. So we'll multiply it now by the image, and we get this is x, and this is 1/2 y. All right, so now we have the full equation was x, y equals x image 1/2 y image. All right, so to put that back into terms that we can actually use, it looks like this: y equals 1/2 y image. And then you would, final step, you would plug this and this into the equation everywhere you saw these and these. So it would be 1/2 y image, replacing y, equals, instead of x, it's going to be x image squared, plus 2, instead of x, it's going to be x image, and plus 3. And then you can simplify this if you so choose, and it's going to become 1/2 y image equals x image squared plus 2x image plus 3. All right, and this is the new equation. So you can see that it's been, the x hasn't moved, but it's been dilated by a factor of 1/2 from the x-axis. Sorry. All right. Now, we could have easily read that straight from this transformation matrix here by using the information you should have in your books from the previous set, which was this little table here. So we could have seen that there was a 1 in the top corner, which means that there's nothing changes, and there's a 2 in the bottom right corner, which means that we have a dilation factor from the x-axis, and we should have already known the dilation factor we read as the opposite, so it sits as 1/2 instead of 2, and it sits with the y variable because it's from the x-axis. So we could have done this really, really easily without using matrices, all right? But the process allows us to see simpler ways of doing more complex problems, even though this one was a pretty simple question. So to recap, the first thing we need to know is what the transformation matrix is, what the original function is. We set it up as just being points. We go through the process. We most likely have to find the inverse, and we have to get out the other end x equals an image and y equals an image, and plug those numbers or variables back into the original function in their respective places. All right, we simplify from there to make the new function or the transformed function. All right, so the goal is to find out what the original points images are and then sub them in.